Here are some integrals to solve. Let's look at one part at a time. The first one is integral sine of natural log of t divided by t dt. I'm going to try to do this using substitution. I'm going to say u is equal to natural log of t. Derivative of u is 1 by t dt. You guys notice that dt by t is already sitting here and natural log's derivative is 1 by t. So that gave me the idea of the substitution. So basically my integral is sine. In place of L and T we can write U, and dt by t can be replaced by du. The integral of that is cosine U plus c with the negative sign. Remember, integral of sine U is negative cosine U. The answer is negative cosine. In place of U need to put back natural log of t plus a constant. Let's work on B. Integral E sine theta cosine theta d theta. I see E has the exponent sine theta, and sine theta's derivative cosine theta is sitting here. So I think my substitution should be U is equal to sine theta. Derivative of U will be cosine theta d theta, which is already sitting in the question. So substitution E sine theta is U, cosine theta d theta is du. Integral of e the power x dx is just ex. So here we will just have eu plus c. U is sine theta, so put it back, plus c. That is your answer. Let's work on part C. Integral from 0 to 1 x e plus e the power x dx. Now it looks complicated. This is a pretty simple. This first one can be solved using x to the power n dx. That's power plus 1 divided by the new power plus c. And the second one, the integral of ex dx is just ex plus c. So using those formulas, this is equal to x to the power e plus 1 by e plus 1 plus e to the power x from 0 to 1. No c here because this is a definite integral. Put 1 in there. 1 power anything is 1 divided by e plus 1 plus e power 1 minus, when I put 0, sorry, when I put 0, 0 power anything is 0 plus e power 0 is 1. Okay, so we have 1 by e plus 1 plus e minus e power 0 is just 1. That is your answer. Let's work on part D. Dx by 1 plus 16x squared. I'm going to try to use the substitution as 4x. Du would be 4 dx. I did that because this thing looks like 4x squared, right? So when I do the integral, dx can be replaced by du times 1 by 4 by dividing 1 by 4. So that dx can be replaced by du, and 1 by 4 is a constant, can come out 1 by 1 plus, in place of 16x square I can write u square. You see 4x square is u square. Now if you guys remember our formula, 1 by 1 plus x squared dx is tangent inverse x plus c. That is the integral formula for. This looks similar, but it just has u in place of x. So therefore this is 1 by tangent inverse of u plus c. 1 by 4 tangent inverse of, what is u here? 4x plus c. E integral 1 by x square root of x square minus 9 dx. This one actually is a straight formula. The formula is, if we have x square minus a square with respect to x, the answer is secant inverse of 1 by a, secant inverse of x by a plus c. So here in place of a square we have 3 square, 9. So a is basically 3. Therefore, this integral is, we can solve the integral straight using the formula 1 by 3 secant inverse of x by 3 plus c. Lastly, let's do this one. Integral of sine inverse of x divided by 1 minus x squared with respect to x. So we put substitution here. Let's do this. Derivative of that is 1 by square root of 1 minus x squared dx. That's already sitting in the question. That gave me the clue actually. Sine inverse of x is u and dx by that is du. Here u's power is just 1, so the integral is u squared by 2 plus c. U is sine inverse of x whole square by 2 plus c. This is your answer to the last integral.